the API, or you mean?
Oh, thank you, Shing.
Yeah.
Um,
Do you mean
no,
the
what I mean is, I am not an expert in like the you know
workload identity?
using this service account token to like
Mhm.
authenticate to other services and exactly how that might work in practice. I don't tend to work in environments where that's the thing that you do.
I
So
can
like
I can show you how.
yeah, it would be
Um,
interesting to see it in practice and be like, okay, here's an actual working example where it's being done, and these are the steps that were needed to make it work. Um,
yeah, I've got something. So, I don't know if I have the demo with me right now. I mean, prepared right now. I did have it last week though. Um, Let me see what I can find. Um, at least to start with, let's go over what the Google Cloud API says. Cloud.google.
Are you sharing anything?
Yeah, I'm just sharing my screen now.
we have Michelle, Google expert.
Oh, perfect. Hi Michelle. Hi. I saw someone else join too. Hi Aaron. All right, so let's get started. Okay, so Ben, to give you a quick background on how workload identity works in Google Cloud or Amazon Cloud follows the same principle essentially. They have something called as a metadata service, and this is a link local web server that runs um, kind of in every host. Um, and whenever you query this web server, it gives you information about yourself. So it's called metadata server, and if it's coming from a container, it'll get information about the container itself. If it's coming, it's like a reflection API. And if the request is coming from a host, you get information about the host itself. So one of the
Mhm.
APIs it provides is a service account token. You can just even call that API
Oh,
and
so I mean, I understand the concept of a metadata service. So I just want to
Mhm.
understand this. So in Kubernetes, like you have it when you have a pod running,
Mhm.
the service account for that pod, the token tends to be mounted into the file system of the pod unless you
Mhm.
specifically turn
Mhm.
that off. So
Mhm.
like you have that in your file system, but what you're saying is there's a different token,
Yep.
or what I want to understand is it a different token or is it the same token just
It's a different
exposed a
token.
second time? It's a
No, it's a
different
different.
token.
Yeah, it's a different token meant to authenticate a workload to talk to the cloud or the
Okay,
infrastructure.
so you're not using your Kubernetes service account token, you're using
Uh,
your cloud
Service
service
account.
account
Yep.
token that you obtained through the metadata service.
Yep. And
That,
every cloud
that's pretty
SDK is
helpful.
already capable of working with it. All we
Okay.
need to do is make the appropriate cloud calls, the API calls to allow that service account token for that pod to access a bucket. So in
Yeah.
terms of orchestration, like really, there's very little that needs to be done. Um, like we're not bringing any tokens and putting it into the pod. We won't even be touching the pod API spec. All we'll need to do is make the appropriate cloud calls to say that the pod that we're going to schedule now, that one has to have the ability to talk to A, B, and C buckets.
Right.
Contents there. Yeah.
So so what I so what the question that this raises in my mind is so that the S3 SDK or the object
Mhm.
storage SDK that you're going to use
Mhm.
knows how to talk to the metadata service. It's going to make an HTTP call, presumably,
Mhm. Mhm.
to some URL.
Mhm.
I wonder how standardized that is.
It's
Um,
standardized. I mean, not across protocols. So S3 metadata server won't look the same as Google Clouds, but the metadata API itself is standardized
okay.
version, all of those good things.
So
Uh,
where I'm going with this is like we could, in principle, not tell the SDK like just use the service account token. We could tell the SDK like, I know the URL of the place where you need to get your token, and this is what it is. And and if we knew that it was, for example, one of these cloud services where the metadata service was available, we could just provide the link to that metadata service. But you could, in principle, provide any other URL that could also perform the same function that might not even be link local, right? I mean,
So
if
you're
we
saying
just,
this would be for vendors?
well, I'm just saying like we have to decide what signal we're going to send down, and what the signal could be, just do your link local thing, and then leave it to
What,
the SDKs to
so
do their
okay.
thing.
So the last week or 2 weeks ago when you were here, one of the things we discussed was uh, we allow or we leave it to the application to go over the set of credential mechanisms that it supports and just work with whatever is available, right? So one of the things we said was we're just going to enable all the things that we can, and SDKs are expected to try different mechanisms for
But
authenticating
but but,
themselves.
the problem I have with that is if we tell them use all of them, and the priority order is not defined anywhere. Like, it could be the case that there are two credentials available, but only one of them has been given access. And if the SDK picks the wrong one because it has a precedence order that we didn't expect, it could attempt to connect using something that isn't going to work.
Fair enough. I think
Right. So
that's
so
a
so
good risk.
we have to know on our side which one we enabled, and send that signal down saying like, hey, this is the one we enabled. And it could be the case that the SDK doesn't need that signal to perform its job because it will discover it anyways. But it makes me nervous because if someone writes a new SDK that has a different precedence order and it picks up on some credential that we never expected to be there, and it's not given access, they will break. And so by leaving it undefined, we're creating a possibility for people to make wrong decisions.
Yeah.
Like I guess in particular, I'm worried about the case where you have both the access key secret and a service account token, and the administrator of the Kubernetes cluster wanted people to use access key secret for whatever reason, but the service account token is still available. And so the workload, if not properly controlled to prefer access key secret over service account token, might just use the service account token and then fail to access the bucket and then not know why, right? Because the admin said, use access key secret in this cloud. I mean, I'm not saying it's a good decision. I'm just saying like they could have done that, because I think what we said was the admin gets to pick which authentication mechanism gets used in practice. It,
I mean, I don't. So that communication has to come in through the API, but I do see the bigger issue that you brought in, which is, I mean, I think it's better to be specific about what authentication mechanism we're passing down. Um, we can do it through the API. It doesn't have to be some mechanism to where the application self or auto discovers, what kind of authentication is provided here. Um, what if we just showed it through the API? Like when the application is deployed, the developer, whoever is deploying the application, gets to know that this is the kind of authentication that this one's going to get. Because it is really an infrastructure concern. It's not an application concern.
well,
Um,
it's a portability. It's a portability concern. So 2 weeks ago, we spent a lot of time going around on like who has to be flexible and who gets to make decisions. And I thought we
right.
agreed that like the applications have to be flexible and the admin gets to make the decision. So an application can't dictate like I want access key secret, or um, I want to use my cloud service account token. It just has to work with whatever Cozy decides to give it. And the admin gets to just make that, if more than one thing could be supported, then the admin gets to pick which one there is. In a lot of cases, we expect there will only be one option, and that's what you'll get. But the workload is sort of at the mercy of Cozy. And so Cozy owes it a signal of, well, we're using access key, or we're using access key secret key on this platform. We're using cloud service account tokens on this platform, and then the workload can ignore that at its own peril, but it's available for people that want to write portable applications that always work. That's sort of my inclination, is to say applications have to be flexible, but we're going to give them a signal so that they can do the right thing.
So I think we need to. So I see what you're saying. Um,
And it has to be part of the downward API that the workload can directly observe. It can't be something at the Kubernetes API level because no one writes automation at that level, right? You just have your YAML for your pod and your image for your application. You want to be able to deploy it on this cloud and that cloud,
but
and
but
and and
then we're expecting the application to have special mechanism for cozy, whereas with
right. This is the cost of this scheme, is that to be compatible with cozy, you have to understand the downward API that we define. And we make it as simple and minimal as possible so that in many cases it's almost invisible to you, but it's there in case you want to, code up in a init container that looks at the values and does something special.
yeah, as long as we can make it ignorable. I still feel like this is like a step two kind of thing. Um, don't you think? Or do you think we need to bake it into the API now?
I think that this is what the downward API is. It is exactly this. It is which authentication mechanism is being used and where is the stuff that you should pull from. And we can try our darndest to just pick file names and path names and environment variables and whatever that would just work most of the places without needing any magic. But we still need to have like a very explicit pointer to say, hey, use this environment variable or pull from this URL or read this file name.
Yeah,
You know,
actually, we already have that mechanism, Ben. The question is what we're going to show in there, I guess. The bucket info.
no, but I mean like a. I,
Yeah, I know what you mean. I think, yeah, I see what you're saying. In the downward
like there
API,
needs to be a top level switch that says
this is the authentication mechanism.
like you should use HTTP and here is the URL, or you should read from a file and here is the file, or you should read an environment variable and here's the environment variable. Some very clear, unambiguous signal about which mechanism is being used, where to find it, and what format it's in. So that someone who wants to be compatible with absolutely everything could do that. And that is the essence of the cozy downward API. And I don't see any way to punt on that. Like,
Okay, I see what you mean. So no, so I'm also thinking of it from the API side, from the user API side. Um, so I think we talked about. So this seems to go against what we talked about 2 weeks ago with you, Ben, which is we kind of said these are all the different authentication mechanisms. This one or a particular bucket access class is going to support. Um, so is that still valid now? If you're going to specify a single one?
the admin can specify one, the workload cannot,
Okay, I see what you're saying.
right?
I see
So,
what
so,
you're saying.
so I
Mhm.
mean, there will be implementations where there is no choice, right? It's always access key secret, or it's always, cloud service account token, and no one gets to make a choice. It is what it is. But in situations where there is a choice, the guy who gets to choose is the admin. That was what I was pushing for, and I thought we agreed to 2 weeks ago.
No, I see what you mean. Yeah, no, that is what you're pushing for. That would also apply. Okay, so what would the APIs look like? Um,
The
so
downward
so
APIs.
no, not the down. So downward APIs is pretty simple to me. We already have a mechanism. We already
But
have a
I want to see it. Like that is the most important thing from my perspective. Nothing else matters if we don't get that right. Um, so that's why I wanted to get into detail on, like if there's a URL that's like points to 169.254.169.254, like, and that's the canonical way of getting your link local credentials from a cloud provider.
Mhm.
Like we could just provide that URL and then but make it possible for the cozy driver to point it at a different URL. And then you would have another degree of flexibility where you could basically be telling the SDK, like, pull your credentials from here. And it doesn't have to be a link local address. It could be more flexible. I don't know if that's a good idea or not, but like,
Uh,
if we're explicit about the URL instead of just saying go talk to the metadata service, it gives cozy drivers another degree of power to say, oh, well, maybe I'll put my credentials over here, and then people will have to pull them. Or maybe I'll define a special metadata service with a different URL. I don't know much about how metadata services are actually built into working clouds because it has to be part of the infrastructure typically for it to
Yes,
work.
yes, yeah. So, I mean, that's the part that I meant was like day two. So why do we need it?
Just more degrees of flexibility.
I mean, like, why is the flexibility needed? Like, I'm asking this question from the
Yeah.
perspective, I just don't see a use
Well,
case. It's
in a situation where you have a Kubernetes cluster that doesn't have a metadata service, but you don't want to use access key secret, one could imagine inventing a new scheme that involves pulling a key from a URL
nah.
that
So,
is
so if you want a
different.
more, I mean, isn't the simplest and the straightforward and the right answer I would say is to use a provider that has this mechanism. Now, what we're trying to do
Probably,
here. Hmm?
probably. I mean, it's just I don't like things being too implicit. Like if we did say, look, it only works with the
No,
link local metadata service, we need to write that down and say like very explicitly, if you get the signal that says you need to use the link local metadata service, then this is exactly what you should do. Go to
mhm.
this URL and get this thing so that no one comes to us later and says, well, my link local metadata service is different and I want you to support it, right? We want to cut off that potential complaint that says, when we say link local metadata service, this is exactly what we mean. And you can't just invent your own and expect us to support that.
Okay, what we're trying to do is exactly that. We're trying to invent our own, or that's what it seems like. See, as far as cloud environments are concerned, all the SDKs around cloud environments are concerned, it's pretty straightforward. It's always the cloud defined URL. Now, when it comes to vendors, they have the freedom to do whatever they want. But as step one, I mean, the way we design the API, it doesn't have to limit us to just the cloud type of authentication mechanism. So let's say we call it workload ID, right? I mean, we can call it anything, just for the sake of this exercise. Um, and let's say I say, the provider is GKE, or the provider is AWS. Um, and then, at that point, it's already pretty, it's implicit at that, with these two providers. Um, we could have, or we could do it like this, say GKE, and we could have fields that go in there, and as we need to expand, we can add more things, like a specific URL if needed. I think you'll realize once we get into this more, you don't need a custom URL as such for these official providers. Maybe for vendors it makes sense, but again, it's pretty straightforward at this point. You in this bucket info JSON, which already is needed for things like, what's the bucket URL, what's the bucket name, and um, where are the certificates located and things like that. I mean, this is a great way to, this can be the great way to deliver the uh, authentication information.
So, I'm looking at the screen and I don't understand what I'm looking at.
Okay, so there's a
Um,
bucket info.json which we pass down to the pod that goes into every pod that's using a cozy bucket. You should, like, we've talked about this many times.
mhm. Yeah, but I mean, like in this specific example, why do we have both GKE and AWS in the
I'm
same
saying these
file?
are all the supported ones. I
Oh,
mean,
okay.
yeah, yeah.
Yeah, it would be
It's
good to
just,
have like an example of a specific one and what exactly you're going to get in that specific one. Because I just want to understand like what would someone
I
be
mean, if it's just GK,
looking
there's
for?
nothing to mention. If it's just AWS, nothing to mention. But just for the sake of expansion, we make it a structure. Right now, it's empty. Um,
Right, but then if a new one comes along tomorrow,
mhm.
what do we do? Do we expand our downward API to support
Yeah,
it?
yeah.
Like, but that's exactly what I would like to avoid.
So you're asking, okay. So you're saying you want a generic mechanism rather than having an infra-specific
Yes,
mechanism.
but because we're going to put a stake in the ground when we ship this API when it eventually reaches GA that says like this is our downward API and everyone must support it. But like,
Okay.
if you follow that up with, oh, by the way, like here's version 2, like now there's now everyone who worked on version 1, like it doesn't work anymore. What we owe to our users is, here is the API and it's never going to change if we're going to ask them to support it completely, right? What I was hoping we could get to was like an API that covers now and forever all the things that we would need, like barring some brand new technology that no one ever imagined.
I
But like
feel like we're
just
complicating it. Um,
No,
I
because it gets even worse. It's worse than that, because then any new vendor has to wait for you to accept them before they can start making use of the API.
yes, that is the problem I see here, is that like we want to create an API that vendors can plug into, that providers can plug into, that users can plug into without having to constantly change the API to accommodate all the
I
new
mean,
vendors
the
and all
great
the new providers.
well, no, the problem is different here. The difference between this and pretty much other infrastructures we've standardized in Kubernetes is that there's a very limited set of vendors or very limited set of protocols when it comes to object storage. There's just GCS. There is Amazon's S3 and
Right. I mean, okay, so protocols are one thing, right? Like work
Mhm,
is needed to add a new protocol. We accept that.
mhm.
But if you ignore all the protocols other than S3, my assertion is any vendor that supports S3 on any platform that supports, a metadata service with any workload that is cozy compliant should just work without ever changing the API. Like, and when it was as simple as access key, secret key, like that was easy to guarantee, right? You just say, look, you're going to get an access key and a secret key. Anyone who supports that, it's going to work. So now we're saying, well, we also care about these, workload-based authentication, and I'm fine with that, but I want to do it in a way that it doesn't require the API to change ever. We do it once and that's it.
So let's talk about it from the perspective of a SDK, a S3 SDK or a GCS SDK. They only work with one specific style. So a protocol specific SDK works only with one specific style of metadata or authentication.
Mhm.
You can't. I just don't see an S3 SDK. Like if you want portability, the portability very much depends on the application layer. And as of now,
Hold
none
on,
of
talk me through the S3 SDK and what
yeah,
it
S3
supports.
SDK specifically. Oh, I can just show you. It only works with S3 style metadata credentials. So AWS.
But is that different on Amazon versus Google versus
Yeah, yeah,
Microsoft?
yeah.
Why? Like,
So wait, when you say different, you mean you're asking if the URL is different,
like,
right?
does the SDK need to know that you're on Google or Microsoft or Amazon, or does it just figure it out?
It just talks to the metadata service, but
Okay,
it
so
expects the
like,
metadata service to be in the same spot every day, every time.
wait, say that last part again.
It expects the metadata service to
Okay,
be available at the same
right.
URL,
Okay.
same
So
SDK.
what I'm saying is, like, if we want to support that, what should go into the bucket.json is use metadata service, and there's no it's not Google's metadata service or Amazon's metadata service or
Fair
Microsoft's
enough.
metadata service. It's just
Yep.
the metadata service.
Yep.
Then anyone who's compliant with that, it just works, and that's the end of the. And then there's no. And then if someone new comes along in the future that supports the metadata service, they don't have to do anything. The API doesn't have to change. They just implement the existing API.
But
That's where we have to be.
that
Is a
was my
place where.
assumption. So,
Okay.
mhm.
But you're putting in here, like, where when you
I,
had the
structure for it.
Amazon and the Google, I was like, no.
Yeah, no, fair enough. So I was putting that in there, Ben, because we were going down this path of having a URL specified for metadata, and I wasn't sure why that was needed.
Oh, well,
Um,
I was just thinking it's even one level more flexible than saying, like, use the standard metadata URL, right? Because if it's the same all the time,
mhm.
we could just provide it and
Yep.
then reserve the right to change it in the future,
Yep.
and just say, like, we're going to give you the URL, go read it, and you'll be fine. And then for the first version, we could always give you the same URL, but it would free us up to, in the second version, give you a
Add more
different
stuff.
URL.
Yes.
But like that's not important, right? If
Yep.
this is the way it's done, we can do it that way. The main thing is with the API, when it reaches GA, we should have zero plans to ever change it, because this is our compatibility. This is our backwards compatibility layer. This is, you write a workload that's cozy compatible, and it's going to work this year, it's going to work next year, and it's going to work the year after. And as more people have more drivers and more people have more stuff, it should just continue to work.
Yep. Yep. Exactly. So that's the download API. So
Yes.
currently the
Yes.
download API. I mean, we can even go a step further. How much time do we have? Okay, it's been half an hour already, but we can even go a step further and just say, what do they call it here? They call it credential provider. Um, Endpoint credentials, EC2 role. Let's see.
I see that Michelle have something to say.
Yeah, Michelle, you trying to signal us? You're on mute.
Oh, yeah, sorry.
Mhm.
No, I think I just wanted to just comment in from a generic standpoint about like the way that we do APIs, but generally, like, unless we have specific use cases where we know that the API is going to work, it'll be pretty hard to come up with an API where we guess what the future might be. I think that's the only generic comment I have.
We guess what the API might be.
Like,
Yeah.
if we try to design an API to accommodate like the future, but we don't have like a reference implementation to it, like, we could definitely just get that API wrong.
Oh, no, right. So yeah, I absolutely believe like we should give people a list of options, and we should spell out what those options are with concrete examples of existing implementations that work that way, and then say like that's it. You don't get any more. We're not gonna. It could just be two things. It could just be access key secret and use metadata service, and those are the only two options. Maybe there's a third that we should also add, but like whatever we do, we shouldn't be planning on expanding it later. We should
well, the way that we design the API in Kubernetes is we design the API as minimal as possible and add later if we need to.
But does that apply to downward APIs that affect workload portability too? Like, because I feel like that's a special case, right?
It's hard to say because the problem is that like we can't predict the future, right? If we try to accommodate possible future things, like we could still get it wrong when it actually comes.
Yeah, I would like to get at least the downward API comprehensive to the point where someone could code, once we reach GA, someone could code a workload and expect it to just continue working for years and years and never to break because we decided to add a feature to Cozy that they didn't know about, like that. And
well, I think in general, like, adding new features needs to be backwards compatible, right? By adding a new feature, we shouldn't break existing users.
Yes, I totally agree with that. But when it comes to like the authentication mechanism, what we've said is we're only going to give you one, and we're going to force you to support the list of possible ones that could exist. And then it's not fair to both do that and say, oh, when we reserve the right to add more that we're not telling you about, because
you
need a fallback. You need a fallback in that case to say, well, if we ever add another one, we'll guarantee that we'll also give you one of the legacy ones that can work too.
Yeah.
Or there would have to be some sort of an opt-in mechanism to say like, I want to use the Cozy 2 compatible authentication mechanisms, and then anyone that doesn't opt into it will get a Cozy 1 compatible authentication mechanism. Or, there needs to be a fallback so that people who don't opt into new behavior don't break.
I think that is something we need to do for backwards compatibility with any new feature, right? So I don't see an issue with that.
Okay. Yeah, your point is taken. Let's go to the next step. All right. So how does this look for a download API? I mean, yeah, this need not be C style. Um,
Do you need the like endpoint URL of the bucket?
yeah, I mean, this is not all of it. Yes.
Oh, okay. Sorry.
Yeah, I was just focusing on the credentials part of it. So I'll just put a dot 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 for the rest of the things. Yeah, you do need an endpoint URL, especially for non-standard buckets, non-standard providers, like AWS GovCloud or AWS China, or just vendor-specific uh, implementations.
So
Mhm.
if say the provider is access key, then is there another like struct with the actual key information in here?
Yeah.
Yeah, there would have to be.
Hmm. And that would also apply to other ones, right? As in metadata service. Maybe metadata service doesn't have anything, but a third one that we add in the future might have fields too.
So like for access key and security, we had different secret, right? Like not will be part of this file, or like that will be a different file, right?
It could be a path name to another file, sure.
That's how we
But then,
started off, but back then we didn't have this structure to pass information down. Something like that. We're deciding it as we speak right now. So
I mean, you might want secret key path, which is a file name that you're supposed to go read to pull the secret out of, in case we don't want to slipstream the secret right into this file.
does it make a difference?
Yeah, because the Kubernetes has a lot of weird technologies for vending secrets into the pod's namespace, like the CSI secrets driver that performs magic as part of making a secret available. It like wants to create it in another file somewhere.
It just uses a memory map file, right?
Yeah, it's all memory map stuff. But the point is there could be other components that are responsible for pulling the secret out of some key store, decrypting it, and then dumping it into a tempfs, into a file of their choosing, and all we can do is just point at that secret.
Okay. So we can call it access secret key file.
Potentially.
Yeah, something like that. So all right, so
it could be two files though, like one for the access key, one for the secret, or maybe the access key is not sensitive and is embedded here, but the secret key is sensitive, is in a separate file. I mean, there's a variety.
So basically, it's a structure. So those are the things we'll add as we go along.
Yeah. We should decide on something, but the specific that is specific, but it doesn't matter what it is until we decide it.
Yeah. Okay. So file or
it's either embedded or it's the path to the place where you read it.
Yeah. So file or values. Okay, let's just call it this. Just a starting out structure.
But I don't want to have two options. I want to pick one and that's it.
Can we not say these two are mutually exclusive? It's either this or it's that.
It just creates more work for the implementers. Every single workload that parses this file now has to have that switch statement, right? Like if we just say there is one way we're going to do it, it makes everyone's life easier.
Fair enough.
Parsing it.
Yep. No, that's a good point. All right, so just that. I buy the argument that it's better to let the CSI secret magic do it. I just like this. Just we can end it at that, right? Or do you still want the access key somewhere?
I don't know. Like I haven't. Again, I'd want to see like an example of this working in practice, and then say like, yeah, this seems usable, and then we can just do that. Intuitively, like I think the access key is not sensitive, and you could safely embed it in the file. And I think the secret is sensitive and should be a file name that points elsewhere. That feels like the safest thing to do. But maybe people do put their access keys in the same secret file as the secret keys, and you have to do some, well, no, because if you have a secret object and you map it into a pod's namespace, you tend to get a file per key in the secret. So you're going to get multiple files anyways. So yeah, you can't have one file. It would have to be two separate files or embed one of the values.
So what was that argument? Why do we need two files anyway?
Well, if you just take a Kubernetes secret and map it into a namespace with a downward API, you're going to get a file per key in the secret, because the contents of those files is not JSON. It's just the raw data of the secret.
Okay.
So you
I
can't shove multiple things into the same file.
Yeah, unless you escape and put it into one field in the secret. But I'm more questioning compatibility with existing SDKs.
Right, and that's why I was saying, like, let's get a working example that doesn't feel gross and convince
so
ourselves that it
maybe we don't
works.
decide it right away, but it's something like this.
Something like that.
Yeah. So I mean, I don't mind putting an access key here, embedded access key, but the secret is there. Access key goes here, and then secret key file, we can call it, and it's just the raw secret key. Yeah, to me it doesn't matter, because I actually want to see the specific protocol specific access key secret key files that already exist, and come up with a scheme that's similar to that. But since I don't have it handy in front of me, this makes sense. So we can just go with this.
Great.
All right. So the other mechanism. So there is still a switch statement. So it's going to be one of the many credential providers. Would that look like this? Or we can do like how Kubernetes does it. Type, access secret key or metadata service.
Yeah.
Something like that. And then if it is access secret key, then you get that sub field. If it's metadata service, you get nothing.
Could be, yeah.
Does that look good? Just for the credentials part. This is the download API. This is where we're going.
Yeah. Change the protocol to S3 from GCS for this example.
Any specific reason why?
Well, I don't know if GCS has access key secret key.
It does. All of them have it. All the vendors.
Well, no, they have it if you come through their S3 compatibility layer. But if you go to the GCS API directly,
yeah, you do. You have access key secret key.
All right.
Yeah. Secret key would just be a string, though, not a path.
Yeah, this is the argument we're just having. So Ben had a good point where there are special mechanisms that different secret providers have, like Vault, and Kubernetes works with it well to securely put the secret into the pod where it can't be stolen easily. So we want to rely on that if possible. By making it a actual string, we lose that ability. But if we were to make it a path, then we can rely on the existing infrastructure.
So then you're requiring it and not giving the ability to use a string.
You're right. We're forcing you to go read a second file to get the secret out. Mm-hmm. Which is, it makes sense from a Kubernetes point of view. Now maybe SDKs don't behave well with that, and we need to do something else to be SDK compatible, in which case I'm willing to change it. But like, again, I want to see concrete examples that are actually working, and then we can evaluate whether they feel gross or whether they have problems.
So the question is, yeah, there's extra work that needs to be done from the SDK side to parse this file, but we're doing this in the
the advantage of this is we never have to touch the secret, right? So it less security vulnerabilities if we never.
They're handed out together though as a pair.
Well, it could be handed off as the handle to a secret that is encrypted in Vault, and that we never have to touch it. As long as we have the handle to it, we can instruct the CSI secrets driver to plumb it into the pod and then provide a pointer to where it's going to be plumbed in, and our hands remain clean.
The secret.
No.
We're the ones creating the secret in the first place.
No,
we have access to it.
The driver is.
Okay.
I mean, you're right. There may be a point at which like it's handed by the driver and we have to shove it into Kubernetes and someone touches it.
Yeah.
But like that could be a secure node where the cozy controller is running. This thing has to run on all of your workload nodes. And
how about this, Ben? How about this? I think it's a little complex. So how about this? I mean, I don't think it's too big of a compromise. If you want something more secure, go with metadata service, we could say, and just have it be an embedded field for now.
Well, or it would be both, right? If you're going to go to the file for the secret key, it would be the access key and secret key. They're a pair.
Right. That's another idea we brought up. And Ben, your point was it's another switch for the implementer to add.
Right.
I think it's
I would be okay with
really
that if SDKs can digest it in that form.
Well, they're never separated, is my point, right? From an object store, they come as a pair.
Yeah, there is never two secrets to one access key, Ben.
Right. It's one access key to one secret key.
Always.
So, and they're in one CSV file.
Yeah, and actually the amount of work we'd have to do to break those two apart is a pain. And I believe in Azure you don't have two different fields. Yeah, there is that.
In Azure, the secret is a large
string, yeah.
String JSON.
Yeah, JWT, I think.
Yeah.
Anyways, so
I mean, if that's what the SDKs want to accept, that's fine. But like, my inclination is then to force everyone to follow that
file pattern
scheme.
I don't mind file pattern for everyone, to be honest. If everyone's going to do file, that's fine. And we can standardize it to whichever file format they prefer. Like AWS has its own way of specifying access key and secret key in a file. GCS does the same, and Azure has its own too. So why not just call it access secret key file? And we really don't have to mess with anything. We just kind of take the secret from somewhere and put it in the access key secret key file.
I guess I was under the impression that like over time the secret for a given access key could change.
No.
Because of things like rotation.
No, you'd rotate both. So when you do a rotation, it would be a new access key and new secret key.
Yeah.
All right. Well, that's fine.
All right, so this is what we have. I think this looks fine. I want to quickly also define the other side of the API, the user side of it. I don't know where we ended up, but I just want to make sure we're all on the same page about that.
When you say the user side, which user?
Okay, so there's admin user and then there's developer. Let's start with the developer.
But this is what the developer sees, the bucket.json.
Okay, so the DevOps person that says I want a bucket.
Oh, the Kubernetes user.
Yeah.
Not the workload.
Yeah,
okay.
Yeah. And let's also have one for Kubernetes admin. All right, so the Kubernetes user is going to be creating bucket access objects so bucket access is namespace now. I'm just going to put and I'm just going to say namespace just to show that it's namespaced. All right, so okay, so then we have so currently what they ask for is they ask for access to a specific bucket. Bucket name. Let's again call it ABC, and so they don't say what protocol they want. they say bucket access class, right? And you know, we go get the information from the different resources from the specific bucket, and then the access class, and then we put the bucket.json based on whatever specified here into the pod. So my question here is, in this model, they don't get to specify protocol and they don't get to specify authentication mechanism too, which is in line with what you were saying, Ben, and I agree with that, which is the admin gets to say what authentication mechanism has to be used in this environment, and the application should just support it, right?
Yeah, that's what I was arguing for.
I like that. I think that seems very intuitive to me. Anyone else, any thoughts on that? So the admin then defines the bucket access class, which has, you know, let's call it ABC. Forgive my inconsistent JSON syntax, but yeah, let's just go with this. So you have bucket access class name, and here you get to say protocol, and let's say they say protocol is S3 and GCS, because above it's, what did I say above? S3. Okay, let's go with S3.
So so in last week discussion, like there was a discussion based like where the protocol should be and where the authentication should be.
Right. That's what I'm going for. I'm trying to solidify that discussion.
Okay, so till now the protocol was part of the bucket class, right? Or like not the part of bucket access class. Oh, I might be wrong.
Sure. Yeah. It was a part of the bucket class. So fair.
Okay.
So the bucket class is the set of properties for provisioning a bucket, and the bucket access class is for properties about the kind of credentials you're getting for that bucket. So let's also call this ABC, and here you say credential provider again.
Authentication
Providers, something like that, and then it's a list. Ben, what were we saying last? Would you remember?
Sorry, what's the question?
So in a bucket access class, would you say multiple credentials providers would go in there, or would you say just a single one for a particular bucket access class? So the trade-off is, if you said there are going to be multiple credential providers, that would mean the application should have to work with one of the many.
Yeah, the application has to work with all of them, but only one of them should be used in practice. And I remember now. Yeah, so my preference was that like nowhere does this show up in any of the classes, and that it's just a driver config option, right? Because
I remember that.
Because if a driver only supports access key secret key, like then there's nothing to configure. The driver's just going to give you access key secret key every time. And if a driver does support more than one, like you can just have a driver config option that says, you know, in my cloud, use access key secret key or use the metadata service. And so then basically,
how would Cozy know this is what it's doing?
There would have to be a gRPC signal come back from the driver saying like, every time you mint a credential, like I'm giving you an SSC secret key, or I'm giving you a metadata. I'm granting access to the metadata. The service account associated with the user. So yeah, there'd have to be we have to figure that out at the gRPC layer. How does the Cozy controller communicate with the driver to establish those secrets? But the format of the secret is the driver's choosing, and the controller is responsible for giving it whatever information is necessary to grant the access. So like for an access key secret key, the controller owes nothing to the driver. The driver just mints an access key and a secret key and hands it back and says, here it is. For a service account, you have to sort of pass down which service account it is so that the driver can go grant the access to the specific service account in question. And so that's going to be a gRPC concern.
Okay, so you're saying there isn't going to be any. Yeah, that would work.
I don't see what's for the configuration should be done in the driver, and the driver should just tell the controller what it's using, and then the controller doesn't need any configuration because it can always find out from the driver what security mechanism is being used. And that makes it really easy to write a driver that only supports one security mechanism, which is what I imagine most of them will be.
How will the admin now specify this is the only mechanism I want? By choosing the driver?
By configuring the driver. Right? If the driver has multiple options, the driver will have a config when you install it.
Yeah, but it doesn't have to be cozy specific config, right? Like we don't.
Right. This is opaque vendor stuff.
Fair
right?
enough. Yeah. Like my question is, do we need something like CSI has the CSI driver object, the API. We don't need that, right? Like a cozy driver. I don't see the need for it. Okay. Cool. Okay. So this would work.
So last week the discussion was happened because for the service account authentication, like there's a question asked is like who should create the service account, whether it need to be provided by the user or like the driver will automatically create the new service account per the bucket access request or something like that. So in this case, like the Cozy driver will create service account for each bucket access request, right? And we need to inject it into the application pod or something like that.
I don't think so. I think that it's meant to piggyback on the service account that your pod would already be using. So like when you create when a specific Kubernetes user creates a bucket access and the controller reacts to that by going and minting the credential, it needs to know the service account associated with the namespace that created that bucket access.
Okay.
So that they can grant access. And it'll get messy if there's more than one, because I don't know what we'll do then. All we know when we get a bucket access is the namespace that it came from. We have no idea what user created it or what account they were using. We just know that it's coming from a Kubernetes namespace, right? So like if that's not going to work, then we need to come up with another scheme.
But there can be multiple service accounts for a namespace, right? Like you can create multiple service accounts.
Okay. So if you look at my screen, you can see how the service account thing works. So yeah, you just specify a service account name inside of your pod, whatever, it can be whatever, and so they call it KSA, Kubernetes Service Account. And in Google Cloud, you create an IAM policy binding that binds a Google service account to a particular role. So you first bind the Google policy role to a particular, Google service account to a particular role. So that's how you grant the Google service account itself. That's how you grant it, permissions for a bucket. So this would be something that I would have to do. Then once that is done, you'll have to ask the Kubernetes service account to impersonate the Google service account by creating an IAM policy binding. How's that different?
So in this world, the pod is actually running with the service account that is the Google service account.
Yeah, Kubernetes service account that's mimicking the Google service account. Yes.
Well, then the only way for us to support service account based authentication is for them to also supply this field in the bucket access request, which we had not been thinking about before.
To specify the service account name, you mean?
Yeah, because otherwise we don't know which service account you mean, right? If it's just all we know is the namespace, and if the namespace has 3 or 4 or 5 service accounts, which one are we going to give access to?
Yeah. I think we always had that actually.
Well, it gets sketchy because now you have to supply a service account name for every bucket access, whether or not you're going to use it, which also feels slightly gross. But I don't see any way around it.
Unless you're going to limit to one service account per namespace.
But yeah, I guess that's not practical because there are plenty of use cases where you need 2 or 3 or 4 service accounts per namespace. But yeah, Cozy needs to know which one so that we can grant the access so that when you create a pod, the access will actually work.
Yeah, it's true. So what's the issue? So didn't we already always have this field though? What's
maybe.
the sketchy part?
Well, no, the reason it feels weird is because if what the admin has chosen or what the driver has implemented is just access key secret key, then which service account you specify will end up getting ignored, right? Because we don't care. Access key secret key is going to work for all of your service accounts. So you could specify Alice's service account, and then Bob could create a pod, and it will still work. And then that will seem strange because it's like, well, wait, I only wanted to grant access to Alice, but why does Bob get access? Well, it's because you used access key secret key, and it's not tied to a service account. It's just a thing that you have. So, you know, we need it for one, and we ignore it for the other, and that creates a strange user experience. But if we want to have a consistent API that is portable, like I don't see what else we can do.
I'm just confused about what changed. Like this is, we agreed on this, and so it doesn't mean just because you agree on it doesn't mean it's always right, but more along the lines of, how is this not a problem before?
I think we hand waved past it before.
I see. Okay, so what you're saying is, we currently, yeah. So we just removed it for for the last revision, because we wanted to make it simple and specifically say that we won't do service accounts. That was kind of our stance. But that was just the last revision. But all along until then, we were saying that we're also going to have a service account field in here, and sorry, repeat your concern again.
My concern is that you must specify it in order for this service account based authentication to work, right? Because if there's more than one, we don't know which one to grant access to.
Mm-hmm.
So if you leave it blank, like we won't know what to do. We can't grant access to anyone.
Right.
But if they're using access key secret key, then they could put a service account in there, but we're going to ignore it. And then it creates a strange situation where you can intend to grant access to Alice, but then when Bob creates a pod,
okay. So now
it still works.
Now, if you
right?
want access key secret key, we specify the credential secret name. Right. So
the controller will, depending on what's been configured, either use the field or ignore the field.
Mm-hmm.
And so it creates a strange user experience where sometimes it's required and sometimes it's ignored.
No, I think we need a clear switch. I mean, we need to be clear. You're right. The user experience would be weird if it wasn't explicit. But
for portability's sake, like the fact that you don't know what's going to be used in any given cloud forces you to do the same thing everywhere.
Well,
right?
I mean, it would be either a named user or a service account name.
Right. And it will matter in some cases and it will not matter in other cases.
Well,
that's what's strange about it.
It should matter in all cases because it's either going to be a defined user or you're going to have a predefined service account name that you're going to use.
Right, but if access key secret key is used and you define, and you have two service accounts, Bob and Alice, and you put Alice's name in the bucket access request and Bob's name in the pod, what's going to stop Bob from using the access key secret key that got created?
I have to drop. I have to finish this machine. I'm using this computer, so I have to end this meeting.
Oh, okay.
I have the top of the hour.
Oh yeah, it is. All right, so yeah, let's discuss on the Slack channel, but I would like to come to a conclusion on this. Thank you, Shing. Thank you, everyone.
Okay, thank you. Goodbye.